Hi everyone, this episode represents an important stage in the car assembly from Cyberpunk 2077. This is the second test drive. Thus we can draw a line under this moment, remembering what was done with Quadra. It's been a long time since the previous test drive, when there was only an empty body on wheels. Since then, a lot of work has been done. Many new elements have been added. The front and the rear bumpers have become more complicated, a muffler has been fixed as well as a new suspension, a new door mechanism, and many other subtle details that are not so easy to remember. Before the second test drive, we need to resolve the issue with the driver's door, also install the glass, make the pneumatic system autonomous, and deal with many other little things. First, I'll tell you about the driver's door mechanism, which slightly diverges from the passenger one. I removed all unnecessary electronics, which I spent a lot of time on, but of course I also got a lot of experience. I took off the door and disassembled all the mechanics. Now I need to repeat everything that I did with the passenger door in the previous parts, but now on the driver's side. The doors must be on the same level and open at the same height, whether plus or minus. Using laser levels, I began the process of positioning the driver's door relative to the passenger door. I plan to repeat the mechanism, adhering to the laser level lines and hinge angles, but it proved to be difficult to align the doors relative to each other. Everything seems to be simple. The starting point is the door opening. You just need to fix the doors according to it and everything is ready. But in an open state, the doors are at different levels. At the slightest deviation of the hinge of the main lever, the door badly changes its position in space, even due to the weld that pulls the metal with it. After spending more than one day, I went through many options and finally managed to position the doors on the same level. All this time I was thinking about how to simplify or maybe even remove the rail. Of course, the rail option is good, but it requires too many alterations, like cutting already finished parts. And just as importantly, cutting the donor's rocker panel so that the hinge can enter it. I decided to attempt the option with another lever to replace the rail. To make it, you need two hinges. Further, for one of them, you need to create a mount on the door frame, observing the angle of the hinges of the main lever. On the lever itself, besides the hinges, there will be its length adjustment, which was made using a screwed socket. The auxiliary lever will have a bend necessary to bypass the lower door seal in the opening. Another adjustment is needed to match the position of the hinges of the main and auxiliary levers, cause this will directly impact the door movement relative to the body. This is why you need to change the length of the lever. The auxiliary lever, unlike the rail, looks very compact and hides behind the door when it's opened. I don't plan on removing the rail from the passenger door, as I want to compare these two mechanisms and choose the best choice. There is no difference in the door automatics. I started with a gas strut installation and a pneumatic cylinder. After adjusting the door, I fixed the locks and connected them with an electric drive. I installed the safety pipe in its place and connected it to the gas strut and pneumatic cylinder. The advantage of the lever over the rail is that all decorative elements remain unchanged, and they just need to be installed in place. The assembly of all the mechanics is complete. The next step is to connect the electronics and compressed air. For this purpose, I'll use another central lock control unit. It turns out that each door has its own control unit. Before installing it, I'll transfer all the wire connections made with twists to connectors. I also put connectors on all the connections made with my own hands. Most amount of the connectors were used for front and rear bumper lights. I installed electronics for each door in that place under that overlay. Up to this point, the compressed air for pneumatic cylinders came from a stationary compressor, which is located in the workshop. It's time to install an individual compressor right in Quadra. This compressor was previously purchased only for the front air suspension, but with the advent of the new elements that consume compressed air, may raise the question whether its capacity and receiver will be enough for the 6 liters. All things considered, this set is quite enough for the front air suspension, and the volume of 4 pneuma cylinders is very small, especially since 2 of them work only in one direction, to lower the safeguard ball. So I think this will be enough, but I'll check it anyway. I wanted to make a homemade pneumatic manifold, but accidentally received the wrong screw cutter needed for fitting screwing, and so far I've connected everything with T-joints. Now we can see how much air spans to open and close the door, and how many cylinders the receiver will last. It takes about the same amount of air to close and to open the door, and in general the cycle takes 0.6 bars. If you turn off the compressor, then with the help of the accumulated air in the receiver, it's possible to open and close the door about 8 times. Afterwards, the air pressure won't be enough to press the door to the opening. In general, it's quite enough, especially since the door can easily work in manual mode. There is also enough air for the front air suspension, but the compressor turns on almost immediately and gradually raises the front bar to its maximum height. This is somewhat similar to the factory version, when the car smoothly rises to the desired height. Now about the remote control. Since now each door has its own central lock unit, accordingly each door has its own remote control. In the future I want to combine 2 key fobs into one and create my own unique design. I also ordered a custom side window of the driver's door and installed a power lift for it. Then, according to the shape of glass, I glued a new opening and installed a seal. Fixing the dashboard is necessary before installing the windshield, as the panel frame has been made in situ and everything has been attached with wire to the car body. I cut off all the temporary fasteners and pulled out the dashboard, concurrently removing the entire wire frame from it. The dashboard will be attached directly under the windshield with 4 screws, which will be hidden under the cover in the future. There will be 4 more screws at the bottom, which I think is quite enough. Now we can prepare the windshield for pasting into the body. First, I removed all the temporary silk screening made with rubber paint for fitting. This time I'm going to make silk screening of the windshield using a primer that is great for this purpose. The surface turned out to be rough, since I had to cover all the gaps with another layer. The rough surface will only be present on the inside, but everything else is perfect on the outside. I applied sealing compound to both the glass and the body without skimping on expenses, because the glass doesn't fit well to the opening in all places. Luckily, I don't have to leave the workshop right off, so a thick layer of sealant will dry for as long as it needs to. As I said earlier, the glass doesn't fit well to the opening in all places, and it's good that it can bend a little. In order there was no ledge and no need to increase to thicken the rack with putty, I pressed the main glass to the opening with self-tapping screws. After the sealant hardens, the glass will remain in its place. Before test drive, we also need to change the oil and fill the car with fresh fuel. Since the last time it was refueled, it was about 5 years ago, what caused the decrease in octane number. At the same time, I'll change all filters and oil in the rear reduction gear. Now we can safely make a second test drive. The control of Quadra V-Tech initially seemed quite unusual for me. I tried to make it very carefully, especially fearing for the front bumper, as in some places the road panels form significant steps. However, little by little getting comfortable with the control, I began to feel more confident and enjoy the ride. I was especially pleased that while driving and turning the steering wheel, the wheels didn't touch the body. My efforts to refine and adjust the front bumper as well as the fenders for the wheels were not in vain according to this confirmation. Since the last test drive, I've noticed visible progress in all aspects. Due to those changes in the levers and suspension angles, the control has become much more comfortable and responsive. Now it's no longer a gizmo, but a complete transport that gives more driving pleasure. In addition, the new doors make the process of landing and disembarkation easier. The glass in its turn protects against wind and rain, which added a sense of safety and improved the overall effect of the ride. I'm very grateful for your support and interest in my project. If it wasn't for your help, I might have given up a long time ago. Your faith in me inspires and helps me to move on despite all the challenges. I appreciate your help and I hope that together we'll achieve great results.